So we have the question where a hydrogen atom is in the state n equals 4, where n equals 1 is the lowest energy state. What is the kinetic energy plus potential energy in electron volts for this atomic hydrogen state? So we know that the energy at a specific energy level equals the kinetic energy plus potential energy, and that equals negative, that's supposed to be negative, 13.6 electron volts over n squared. So we just plug in 4 since we're at energy level 4, and we get negative 13.6 over 4 squared, which equals negative 0.85 electron volts. So the next part of the question asks, the hydrogen atom makes a transition to the state n equals 1. What is the kinetic energy plus potential energy in electron volts for this lower atomic energy level? So we do the same thing as the last question, except this time we plug in 1 since we're at n equals 1. And that is negative 13.6 electron volts over 1 squared, which is just negative 13.6 electron volts. So now I'm going to ask, what is the energy in electron volts of the photon emitted in the transition from n equals 4 to n equals 1? So we do the work energy principle, and this time it's energy final equals energy initial plus the kinetic energy of the photon. We plug the two products we found there, which are the two energies, energy final and energy initial, and we end up getting 12.75 electron volts, and that's the energy of the photon and also the kinetic energy of the photon. And here's just a graph of the transition that the photon made from energy level 4 to energy level 1. Thanks!